Not that complicated. With Ava and Jacob.
Hi there, and welcome to Relative Velocity with Ava. Let's first read the problem. So, two planes are flying in the air. Plane A is capable of flying at 724 kilometers per hour east, and plane B is capable of flying 826 kilometers per hour west when there is no wind. If there was a wind blowing at 261 kilometers per hour east, 19.6 degrees south, what velocity will plane A think plane B is traveling while both being blown by the wind? So let's start answering part A. And a good thing to keep in mind when answering part A, or really what the key thing is to know when doing part A, is that both planes are being affected by the same wind, which means that their relative velocity to one another does not change if there is a wind or if there isn't a wind, because they are both being affected by that factor. The relative velocity formula is the one as follows. VAG is equal to VAB plus VBG. And what does this mean? Well, it means that the velocity of plane A relative to the ground is equal to the velocity of plane A relative to plane B plus the velocity of plane B relative to the ground. I know that this formula doesn't seem too intuitive, but it does make sense when you kind of rearrange it or play around with the variables. It's also really good to keep in mind that these subscripts are completely interchangeable as long as you keep the pattern the same, and that keeps the relationships the same as well. If you want to go more in depth about how this formula is derived and how you get to this formula, just let me know in the comments or send me an email. Now that we have our formula, let's start by putting down our given information. So we know that the velocity of plane A relative to the wind is 724 kilometers per hour east. And we know that plane B relative to the wind is at 826 kilometers per hour to the west. Now, in this problem, I am using wind because it says when they're both being affected by the same wind, but you could also be using ground in this instance. Honestly, I probably should have used ground since the wind is not really affecting the plane's velocity, but I just put it there in order to kind of make it clear that it doesn't really matter in this case because they're both being affected by the same wind, so their velocities relative to each other remain the same. So now that we have our relative velocities written down, we have to make sure that we determine the direction that we are going to use. And obviously your direction can be arbitrary, but it is usually used that east is positive and north is also positive, which means that here our west direction, which is velocity of B relative to wind, will be a negative value. So I'm just going to scroll back up to the problem and see where it tells me what we are looking for. So we're looking for what velocity plane A will think plane B is traveling on. So that is velocity of plane B relative to A, because this is what A is thinking. That's how you can think about it. That the second variable or the second subscript is what that plane sees. With that said, we can then follow the pattern of the subscripts that we put in the general formula and put that here. So you can take a little bit of time to look at that and see how those numbers do match up. Or you could also take the formula from the top and rearrange it to get VAB isolated, and then the negative version of VAB would turn into VBA. And we use that relationship here as well on this step, where I turn VWA into negative VAW, because we can just flip the order of the variables, and then that changes the sign that is before it into a negative. So with that said, let's write out our given information. We have velocity of B relative to W equal to 826 west minus the velocity of A relative to W, which is 724 east. Now we have a negative that makes 826 negative, and then we have the negative that was there since we switched the direction. Now with that said, we end up getting negative 1550 kilometers per hour, which is actually 1550 kilometers per hour west. Now we can move on to part B. So in part B, it asks us, what will someone on the ground think plane A is traveling? Now, it asking us what will someone on the ground think, that means that we're looking for the variable that is velocity of A relative to ground. Because remember, we are looking, the second subscript variable is what that variable sees, right? So we're looking at what does the ground see? How does the ground see plane A? So here I'm just writing out what the other variable information that we were given from the previous question, which was what the direction of the wind was coming from, and that was east 19.6 degrees south. You can go look at the question again because you see that it's given near the end, and then I'm just rewriting our given information. So we're looking for VAG, which is what I previously explained, and then we can then follow the same pattern that we followed at the beginning, so don't be afraid to go reference that formula until you've got that pattern down pat. And so I've just rewritten my equation, and now we can just sub in our values. Now, you may be wondering what makes part B any different from part A? Well, it's the fact that in our velocity of WG, we actually have two directions. So what I'm going to do is draw out a diagram for this wind velocity so that we can see which components are in the Y direction and which components are in the X direction. So using trigonometry, we can then identify what the value is of the velocity from the x direction. So in the above question, the solid line is in 261 kilometers per hour, right? So we can take that and end up taking the component of it, which is by taking the adjacent side, which is cos theta. Since we're given theta, we can then just take cos theta, which gives us the value of the adjacent side. So that's going to be 261 cos 19.6 degrees. Now, you can go ahead and put this value into your calculator, but I like to just write it out like this and then use that value later. Now, also important is to write your direction. There you see I wrote east because it's so easy to get lost in your problem and forget what your direction was at the beginning and make little mistakes. So although it seems obvious that it's in the east or obvious that VWG is in the south, it's so important to write that down. Now just quickly, VWY, that's why in the y direction we're using sine theta since it's the opposite side. Now we can go back up to our formula and now we can focus on two different directions. So we have to look at all of the influences in the x direction and then all of the influences in the y direction. Right now we're focusing on the x, so I'm going to sub in the VWG that we just previously calculated for x. You can go ahead and type that into your calculator and you're going to get a value of 969.9 kilometers per hour east. Now that we have done that, we can move on to the y direction. Now in the y direction, I am copying down that same formula from above, except this time the VAW is not going to have a value. As you can see here, I'm demonstrating that it is equal to 0, and that's because our VAW has only ever been in the east direction, which means that our VAG in the y direction is just going to be equal to the velocity of the wind in that y direction. We can then go ahead and calculate our result. Since we have components, our result is not just the sum of both of them, but you have to do vector addition, and this requires drawing a vector diagram. Now what I have drawn here is my resultant vector in pink, which is what we're looking for, and my two components, my VAGX and my VAGY. Now, in this case, we have a right angle triangle, which means that we can use Pythagorean theorem, and that requires taking the square root of our x squared plus the square root of our y component squared. Once you put that into your calculator, you're going to get a result of 973.8 kilometers per hour, but that is just the magnitude of the velocity and not the direction. So in order to find the direction, we have to go and solve for theta, which is what I just put over there. The thing about choosing your direction is that you can actually choose it from either corner, but I choose that corner because that's where I'm, saying that my arrow starts, but you could have chosen the corner at the bottom and used a different ratio. Now, I use tan theta because that is what uses your two sides that are not your hypotenuse. So you can remember SOHCAHTOA, hopefully, and you know that tan theta is equal to your opposite over your adjacent, which means when you take the inverse and solve for theta, it is also equal to your opposite over your adjacent, which is what you have seen here. We have y over x. Then when you put that into your calculator, you get 5.16 degrees, and then you can write out your final answer of 973.8 kilometers per hour east, which is our original direction, and then you're going downwards by 5.16 degrees in the south direction. So that is how you write your directions. With that said, that concludes our problem.
Thank you for watching Not That Complicated. Don't forget to like and subscribe.